Hi, my name is Kovács Márton and I am a PhD student at ELTE Chemical Kinetics Laboratory. My research area is testing and development of detailed combustion reaction mechanisms. In our previous video, entitled Testing a Combustion Reaction Mechanism, I have discussed briefly that XML format data files can be used for the storage of the complete description of a combustion experiment and the experimental results. It is very useful if such data files are accompanied with a code that is able to create, read and process the data files. In our case, this is the Optima++ program. Our group started to use the Prime Kinetics data format, which is an XML format for encoding combustion experimental data. Having worked for several years with the Prime format, we decided to use an extended, not backward compatible version of it that we call Respect Kinetics data format or RKD format. The latest version is 2.2 and there is the corresponding documentation on the Respect website which contains the detailed format specification. Here is an example of an RKD data file. There are three different types of RKD data files which are defined in the first tag of the file called the root element. It can be experiment corresponding to an indirect measurement, K-determination corresponding to an experimental or theoretical direct determination of a rate coefficient, or XML info containing additional information for the description of an experiment. An RKD file consists of four main parts. First, the facts about the XML file are given, which include the ID of the person or research group which created the XML file, it is the file author, the unique DOI of the XML file, this is the file DOI, the version of the data file, file version, and the version of the RKD format, respect version. If an error is found in a published XML file, then the file version number is increased and the old file is replaced by the new one in the respect database. In the past, the RKD format was revised in several steps and the newer versions allow inserting additional types of information to the data file. The RKD files are all backward compatible. If an RKD file was modified in such a way that the experimental data in the XML file remained identical, but the RKD format was upgraded by inserting additional information, then the file version remained identical and the respect version is corrected. The second block contains information about the source of the data. If the origin of the data is a journal article, then this block contains the DOI number of the article, this is the reference DOI, the bibliographical details of the article and the exact location of the experimental data within the article. The third block is the common property part, which contains the constant or initial experimental conditions and other common information valid for each data point. The fourth block is the data group part, which contains the actual data points of the experimental or theoretical results. In each RKD format XML file contains a dataset. A dataset includes those data points that were measured on the same apparatus at the same time at similar conditions except for one that was systematically changed. The text on the article has to be used to understand the experimental method, the initial temperature and pressure, the initial concentrations, and so on. At the measurement of ignition delay times in shock tubes, the experimental definition of the ignition delay time is usually based on the measurement of pressure change or the concentration profile of some species. Exactly the same definition has to be used at the simulations if we want to compare correctly the experimental data and the simulation results. I agree that an RKD format file looks fairly complicated at first sight, but fortunately you don't have to create such files manually. In the coming minutes, I will show how such a data file can be created easily using the graphical user interface of our Optima++ code. The data themselves may come from your own experiments or from published papers. The procedure is almost identical in the two cases. In the articles, some experimental data are given in the supplementary material in the form of Excel tables or text files, while other measurement data can be read from the figures of the article. In the latter case, you have to digitize the content of the figures first. Let us assume that you want to encode a dataset from an article of Altenberg and his coworkers published in the journal Combustion and Flame in 2016. Now I use program Optima++ for the creation of an RKD data file. Optima++ can be downloaded from the Respect information system from webpage respect.hu. I have downloaded the article and its supplementary materials and saved them into this folder. This is the article. I will encode the first dataset reported in the Excel files given as a supplementary material. If I click on the Create RKD Format XML Data File button, then a wizard window will show up where I can select a template to start with. These templates are useful if you are encoding your own results, because you can create a template containing your not changing data and reuse it during the preparation of multiple XMLs. In the next page, I can select the experiment type. I will encode now ignition delay measurement data, so I will select the first option and click on the Finish button. In this window, I can edit my new XML file. As you can see, here we have 4 tabs corresponding to the 4 main parts of the XML file. You can edit any field by double-clicking on it. In the File Info section, I update the File DOI field. The ignition definition is the last entry in this section. If we double-click on it, we can define the measured quantity and select the type from the drop-down menu. In the Burke et al. Article, the ignition delay time is defined as the maximum of the dP per dt profile, so the default values are fine. On the next tab, I can edit the reference of the experimental data. I have downloaded the BibTeX file of the selected article from the web page of the journal. I simply drag and drop this file into the reference section, and the relevant fields will be automatically imported from the BibTeX file. Now I add the new location field, which contains the location of the data to be encoded within the article. In the right-click menu, I select the Add New Field option, and in the combo box I choose the location field. In this editor window, I can type in the value of the location field. In the next section, I set up the common experimental conditions. The initial composition will be inserted here. Right-click, Add New Property, and here I select the composition property. Let us start with methanol. Its amount is 5%, so I type 5 into the value field and set the unit to %. I set the source type to reported and type CH3OH into the name field. If I have typed the name, all other fields are filled in automatically by clicking on the small magic button. Now I'm ready with the methanol composition. I repeat the same things for the oxygen and nitrogen data. In the last section, I need to provide the varied data of the experiment. First, I define which properties were measured. So right-click, Add New Property, and select Temperature first. It is up to you in which order you define the properties. In the property editor, I have to define a unique ID for the property. I will use IDs x1, x2, and so on. The label will be T. The source type is reported and the unit is Kelvin. After clicking on the OK button, as you can see, a temperature column appeared in the bottom section of the window. Now, I quickly add the pressure and the ignition delay properties in the same way. Now I can insert the measured data in the bottom table. So I copy the corresponding columns from the supplementary material to the system clipboard. It is not a problem if the columns of the data are not in the same order as listed in the XML editor, or if there are extra columns. I select the Paste Data from Clipboard option from the right-click menu of the XML editor window. In this window, I can set up how the data in the clipboard are utilized. For example, I can overwrite the existing content or append rows to the end of the table. In the middle section, I can reorder the columns. The first column is for the pressure data. The second is for the temperature. The third column contains 1000 K per T data. We will not use it, so I select the Not Used option. The last column is the ignition delay. If everything is fine, I click on the OK button to accept it. Now our XML file is ready. We can save it by clicking on the floppy disk icon at the top of the window. I have shown how ShockTube data published in an article can be converted into an ArcED data file. There is a series of well-established experimental methods for the investigation of the chemistry of combustion systems. These are laminar burning velocity measurements, ignition delay times measured in shock tubes or rapid compression machines, concentration measurements related to reactors like shock tubes, jet reactors, flow reactors, and also flat flames. All these experimental data can be easily encoded to ArcED format using the Optima++ program in a similar way. Some final comments. Our group has created several thousand ArcED data files and published them in the RESPECT information system. These data files provide an almost complete coverage of the experimental investigation of the combustion of hydrogen, syngas, methane, methanol, ethanol, butanol, and ammonia. Also, many experimental data are available for combustion systems in the presence of nitrogen oxides. We suggest to look for a given set of experimental data in RESPECT before you start encoding an ArcED file from a journal article. Experimental data published in a journal article are dormant and cannot be used directly. Encoding published data in ArcED format files allow an easy and efficient utilization of their information content. The encoded ArcED files can be preserved in your archive only, or you may publish them in your website. However, we are also ready to host your data in RESPECT with the full credit to the person who created the ArcED file. Usually, the experimental data measured in a laboratory are stored in a paper or electronic logbook. The student who did the measurements graduate. The unpublished data and the fine details of the published data may become unavailable in a few years. The typical reasons are that the electronic logbook system is replaced by a new, not compatible one, and the paper logbook doesn't contain all details. We suggest encoding of all new experimental data in ArcED format. This is a both human and machine-readable ASCII data format which allows a permanent storage. In our previous video, entitled Testing a Combustion Reaction Mechanism, I have shown that if an ArcED file is available for the description of a combustion experiment, then the experimental data and the simulation results can be compared easily using program Optima++. Thank you for watching, take care.